You know that feeling, right? You're staring at a progress bar that says compiling shaders, and you're just wondering what on earth your computer is actually doing. Well, you're not alone. Today, we're going to pull back the curtain on that whole process, and we're going to see how all that waiting is actually building something pretty incredible for the future of gaming. Let's get into it. So let's start with the problem itself. It's a massive headache for game developers and even just hobbyists, something that can bring even the most powerful computers to their knees before a single thing has even been put into a scene. And you can just feel the pain in this post. This isn't some minor bug report, it's a real cry of frustration from a user on the Unreal Engine forums, and it captures a feeling so many people have had, hours, literally hours of your life gone, just staring at a progress bar for a totally blank project. And just look at the sheer scale of this. We're not talking about a dozen little programs or even 100. We are talking about thousands, up to 8,000 separate little tasks that your computer has to just grind its way through. And the cost is very real. While this is happening, your computer's brain, the CPU, is often just pegged at 100%. Your whole machine becomes a slug. You can't do anything else. And I gotta say it again, this isn't for some huge complicated game world. This is for a completely empty file. So what in the world is the engine doing? I mean, it seems like a crazy amount of work for nothing. Is it a bug? Is the system just flawed? Or is there some hidden, crucial complexity here that we're just not seeing? That's what we're here to find out. All right, to solve this mystery, we first have to understand how your computer takes a bunch of code and some 3D models and turns them into the picture you actually see on your screen. The best way to think about it is like a super sophisticated assembly line, but instead of building cars, it's building pixels. Now, the official techie name for this assembly line is the graphics pipeline. It's the core process that takes that virtual 3D world, with all its data about shapes and colors, and just step by step translates it into the flat 2D image on your monitor. And we can really break this whole assembly line down into 3 main stages. First up is the application stage. That's where your computer's main processor, the CPU, gets all the data for the scene ready to go. Next, it's handed off to the geometry stage, where your graphics card, the GPU, figures out the exact shape and position of every object. And finally, there's rasterization, where that same GPU basically paints the final image pixel by tiny pixel. So where's the bottleneck in this pipeline? Where does our slowdown happen? Well, for that, we need to zoom in on one specific component. It's the thing that gives this whole process its incredible power and flexibility, but it's also the culprit behind those marathon load times. Let's talk about the shader. So what is a shader? It's really just a tiny, very specialized program. Its whole job is to give instructions to your GPU during that final pinting stage. For every single pixel you see, a shader is there answering the big questions. What color is this pixel? How is light hitting it? Is the surface supposed to look shiny or matte or rough? Literally every visual detail comes from these little programs. Okay, that makes sense. Shaders define how objects look. But that brings us right back to our central mystery. Why on earth would a scene with no objects in it need to compile over 8,000 of them? Well, the answer is pretty surprising. And here it is, the big reveal. That empty scene, it's an illusion. It's not empty at all. It's actually preloaded with a bunch of stuff. You've got the default sky, which has its own complex material. You've got materials for the hidden editor tools themselves, like the camera. Their default lights, atmospheric fog. But the real kicker? The engine is preparing a massive library of potential shaders. It's pre-compiling thousands of variations for any kind of material you might decide to use later, so it's ready for anything you throw at it. So, we've figured out the what and the why. It's a ton of prep work. But is all that waiting actually worth it in the end? The answer is a huge, resounding yes. And the payoff? Well, it's absolutely stunning. Take a look. The whole reason for all this heavy lifting up front is to make a certain kind of technology possible. We're talking about something that, until pretty recently, you'd only see in pre-rendered movies from places like Pixar. And that technology is fully dynamic, real-time global illumination. In simple terms, it's about making light in a game behave just like light in the real world. See, in older games, lighting was pretty basic. A light source would hit a surface, and that was pretty much the end of the story. We call that single bounce lighting, and it created these really harsh, unnaturally dark shadows. The new way lets light bounce around multiple times. So light comes through a window, hits the floor, then bounces off the floor to light up the wall, and that wall then casts its own soft glow on the ceiling. It's just natural. And you can see the difference right here, clear as day. On the left, that's the old method.
Notice how the shadows under the sink are just pure black? The whole room feels a bit flat. Now, look to the right. With multi-bounce lighting, the scene just comes alive. That sunlight bounces off the floor and softly fills in those same shadows, making the entire room feel connected and real.
This incredible tech has a name. It's called Lumen. It's the global illumination system that's built right into Unreal Engine 5. This is the payoff for all that shader compilation. It's the engine behind this new wave of photorealism, and honestly, it's a total game changer.
So we've gone from a super frustrating loading bar all the way down into the deep technical systems that are completely changing what's possible in real-time graphics. But what does it actually look like when it all comes together? Let's see the final result. The end result is this. Scenes with just staggering complexity and realism, where light and shadow dance across every surface with the same beautiful subtlety you'd see in the real world. And remember, this isn't a pre-rendered image from a movie. This is a world you can walk around in, and it's all being calculated on the fly 60 times every second. So, that 8,000 shader problem, it turns out it isn't just a bug that needs to be squashed. It's the necessary price of admission for a future where that line between what's virtual and what's real gets blurrier every single day. Which kind of leaves us with one last question to think about. We're achieving a level of visual realism that was pure science fiction just a decade ago. But as we get closer and closer to that peak, maybe the next great challenge isn't about adding even more power, but about making all of this incredible power feel effortless for the people who are actually building these amazing worlds.